Hey everyone, welcome back to Thinking of Pi. Today we'll be taking a look at thermistors. Thermistors work very similar to photoresistors, however the resistance varies with temperature. Now there's two different types of thermistors, NTCs and PTCs. The PTCs is positive temperature coefficient, and when the temperature goes up, so does the resistance. With NTCs, like the one I'll be using today, the resistance actually goes down as the temperature goes up. These make things a little bit easier, so you don't have to worry about the resistance cutting off your voltage, so it works very well as a temperature sensor. Let's take a look at the circuit. So you can see here that the circuit is identical to last week's. However, I've replaced the photoresistor for this thermistor right here. Everything works pretty much the same way. I've got it wired over here to the PCF on pin 0, and all this is the same. Still have the LED in here, not using that today, but I didn't feel like taking it out. Now with this thermistor, I don't know the limits on it. I don't have a data sheet for it. I'm tempted to test the limits with a lighter, so I might try starting on fire. Haven't decided yet, so stick around and find out if my Raspberry Pi survives. For now, let's go look at some code and make this thing work. Alright, so we've already got the code put together here. Most of the stuff at the top here is going to be the same as it was in the previous video, so I'm not going to go into detail with that. We've got our analog read, analog write, and right down here is going to be the important stuff that I really want to talk about. So first we're going to be reading our analog value from channel 0 on the PCF. Then we're going to be calculating the voltage from that. From that we will calculate the resistance. And then we'll use that to calculate the temperature in Kelvin. You can see the formula right here. I'm not going to go into the math. It varies depending on the type of thermistor that you're using. We'll then use that to calculate the temperature in Celsius, so it actually means something to us. And then we'll print the value down here, and we'll be able to see the variation in everything. So let's run this program and see what happens. Right now, it's just reading the temperature of the room, roughly 19.6 degrees Celsius. But we can see the difference in values here. We've got the raw analog value, and then the voltage, and then our temperature over here. Now when I put my fingers on here, you can see the values start to change. My fingers are kind of cold, so it's not changing very much. But there you can see it actually holding on to a little bit of the value as it starts to cool off. Now I did decide that I am going to use a lighter and see what we can do with this. So I'm just going to stick the lighter right up to the thermistor. Hopefully it doesn't burn anything. There we go. You can see it starting to heat up. Just over 100 degrees. And there it goes. Now we can see that it's a math domain error, which basically means that it's reading 0 in this case and it can't calculate the value. But it topped out here at about 239, so we could assume that being the upper limit for this thermistor. It's probably dead now, but whatever. Anyways, for next week, we'll be looking at a joystick, so that should be exciting. Raspberry Pi is still working. If you enjoyed this video, make sure you give it a thumbs up, subscribe to the channel, and I'll talk to y'all next time. Now, as I was wrapping things up and turning it off, I decided to run the program again, and it actually still works. So, I'm glad to see that I didn't actually ruin anything.